Okay, so what I wanted to do is show the process for essentially transferring a planned implant case from ExoPLAN back over to exoCAD so that you can start making some pre-surgical parts. So let's say you might want to make 2 provisionals for this case for number 8 and 9, or maybe 2 custom abutments or something like that. So basically this is the final plan or implant plan for this patient. So we have access channels coming out pretty much mid incisal edge. Something to just kind of keep in mind when you're planning this, just a quick sort of note, is notice that we can visualize the hex here of the implant, and this is like an implant dummy, but we can essentially time that hex right there, and you notice that the tip is pointing out to the facial. So these are 3i, or I guess Zimmer Biomet 3i certain implants, and with this system and the tie bases that we use, so we use MIST tie bases, so your tie bases could be totally different, but our tie bases for angled screw channel are timed such that the tip of the hex, basically the angled screw channel, the notch out of the back of the tie base, out of the pallet, is directly in line with the tip of the hex. So it's not in line with the flat of the hex. If it was lined with the flat of the hex, it would be kind of coming off like in this angle. But since our tie base is the notch cut out of the back of the short tie base for angled screw channel is timed to the tip of the hex, that's why we have it designed like this. So we know that when I have angled screw channel, I'm going to be able to angulate that straight back to the pallet, versus like angling it off to the side. So obviously you're going to have to know your tie base and how it's timed to your hex so that you can time your implant appropriately. But the point is to time it correctly in your planning software, because if you're able to transfer this information from plan to actually manufacturing something, that's an important information to transfer. So with ExoPLAN transferring over to exoCAD, all of this information is transferred, which is one of the reasons why I think this is it's a very helpful tool. So what we're going to do is basically open this project up in exoCAD. We're going to use the same start screen. We're going to open up the case. As soon as we open up the case, it's going to basically look like this. All right, and we're going to import implant planned info file. It's going to walk you through a few different steps here, like a CT and alignment object. We're going to use that. And then it wants us to load up some extra scans. So we're going to do pre-op scan, and this is actually, I have to remember. Let me double check this really fast. Yeah, that looks like a pre-op. Okay, so here's our pre-op. And then our lower jaw. And let's just make sure that that is all making sense. Okay, that looks like it's the right alignment there. And then obviously our pre-op is out of alignment, but we can fix that. All right, so okay, great. So this is we're going to correct our pre-op scan. I'm just going to move this totally out of the way. Hold Control, rotate it around so that's kind of in the right view. Make sure that looks good. And then by clicking automatically here, we can do the basically the 3-point alignment. So I want to bring the pre-op into the scan data because the bite and everything else about the arch is aligned. So I'm going to click 3 points really far apart, get a nice little tripod there, press perform alignment, and then press best fit matching. So this is just a common, anyone who's familiar with exoCAD, like this is, you do this every day. This is aligning meshes. Okay, so that's good. Now we'll move next. We're not going to do the articulator. Okay, so here are our implants. This, as you can see, based on the implant planning, put right into the jaw scan. It already tells us what implant we're using. So Zimmer Biomet certain, the size, and we're going to do, I'm going to do 2 different kinds. I'm going to do one of each different type. So let's do, we're going to do screw retain for both because these are essentially temps. And I'm going to do one on a tie base. And since it knows the implant and it knows the libraries that we commonly use, it's basically going to give me only one option for a tie base. I'm going to choose, so again, here is S-Link. So let me just show you this. So see the notch on the back of the tie base? That would be our angled screw channel. So notice how it's timed to the tip of the hex. If it was timed to the flat of the hex, this would be off, like a little bit like that, and it would be hard to get a pure buccal lingual altered screw channel. So timed really nicely there. We're going to do one on a tie base. We're going to adjust our fit to whatever we do, and we're going to click next. We're going to go into the next tooth, still screw retain, but I'm going to do direct to implant this time. Tell it what library to use, and we're going to do so on ours. And if you have exoCAD, you may have different options here based on who your vendor is. So pre-fit would be like a blank of titanium. Disc milling is literally milling the platform. So we're going to be printing the platform with a 3D printer. And I would not do this for provisional ever, to print directly to the platform, because the plastic underneath your screw is too thin. That seating surface of plastic underneath your screw is too thin. So I wouldn't want to do that, but I just want to show you the process of essentially design, because it's going to be really similar whether you're doing a crown, like a provisional, pre-surgically made provisional, or a custom healing above it. So this step is not very important. I just want to make a very quick circle here. We have a lot of control in farther steps. So same thing with number 9, turn the pre-op on, and sometimes if the pre-op is too, I guess, dense, like if you can see it too much, you won't be able to control these control points along this line. So knock your transparency down, and then you'll be able to drag control points easily. Again, those circles are not important, so just put them down and move on. Okay, A for antagonist is a shortcut to get the antagonist jaw, whether it's upper or lower, get it out of there. So recently, I sort of learned that it's helpful to make, when you're adapting to pre-op, it can be helpful to make your pre-op tooth a little smaller than, it makes your anatomic tooth, the thing that I'm moving, a little smaller than your pre-op, and it helps for that tooth to adapt better versus having it bigger. So I'm going to just place it here, make it a little smaller by holding shift and sort of moving my mouse. So when I do that, I hold shift and I move my mouse in and out, and I'm going to make it bigger or smaller that way. And I'm just going to kind of hide it within this pre-op and move on. We're going to adapt that later. Okay, so I'm going to turn off the alignment object, which is the thing that was opaque. And then now I can see, and I'm going to turn off my full anatomics. I don't want to see them. I just want to see my pre-op pretty much. And I'm going to hold shift. And at this point, if you're familiar with implant design, I mean, basically we're making 2 implant crowns here. So it's really no different from that. But if you're not familiar, just follow along. I'll kind of walk you through sort of my process here, and sort of the way that I was taught. So I want this facial border to really support the tissue and line up right along with the emergence of the pre-op. So if I hold shift and double click on a pink dot, all of them turn green, which means you can move them freely. Holding control and clicking on the line, add some control points there. So this is where I'm really starting to kind of dial in. Sometimes they unclick on you. They go from green to pink. But I'm going to really dial in the support and the emergence of the crowns. Okay, bring this out. I really like to zoom in on this. I don't know. Maybe I'm growing blind. But I like to really see close up. I imagine if you're not the one driving, this might be a little bit obnoxious to be this close, but it really is helpful when you are driving, I think, to see that. All right. So I don't want to get too close to the gingiva, but I definitely want to support the emergence there. So I like to have a control point mesial distal, sort of like this, and then a few control points on lingual. And if you need to err on more control points, I think having them on the facial is better. Let's bring this a little bit more kind of middle there. Same thing here. I can't add a control point easily. I gotta sort of see that line. There we go. Okay. Let's expand these out. Expand that one out. Bring this one up. So I don't mind if I'm sort of seeing my margin, because remember, this is going to be a one piece, basically tooth on a tie base. So that margin is just going to be part of the crown. So this does not bother me. Now you see this seam here. We can get rid of that by going to advanced and reducing our height and to 0 of our profile borders, and that seam goes away. Click back on bottoms. I'm going to turn off the jaw scan, which is S, and now I'm going to work on this profile. So, the way I've been trained, and I think generally the current understanding of emergence profile and implant is sort of hourglass shaped. You want the bottom angle to be pretty straight and the top angle to flare. And if I can create that here, see how now that's quite straight, and then up here it starts to flare out like that. That creates the most amount of tissue thickness right here around the implant, and then you start to flare out and support your tissue. So you have this sort of hourglass-like effect. Okay, I see this and I don't like that. I don't know what's going on there. That makes me suspicious. So let's turn back on this jaw scan data and just look at that. I think that's kind of an error. So let's bring that just straight out to support that tissue. That looks better. Okay. It might be worth pushing this gingiva a little bit more to give this a little bit more support and expanding that out. Maybe adding a control point here and just pushing this a bit, just to give that tissue a bit more support there. Obviously, we've lost a little bit of papilla height. Okay, let's move on. So we've set our gingival emergence. So that is what I spend a little bit more time on. The other, let me go back really fast. The other thing you can do is this freeform tool is really helpful if you have little ripples or areas of your emergence which look a little thin. When you turn on freeform, you can just hold your left mouse down and kind of just push around the area that you want to expand. I don't really see an area that I want to expand, but I could maybe expand this area. I'm going to click and see how it just kind of grows out in the same contour that you've established. So that's a freeform tool. I use that a lot. That's sort of how I was taught to work on this too. All right, so here are our crowns. They look pretty crummy right now. I don't care, so I'm going to just move on to adapt. Basically, I want to get to the adapt to pre-op part, and now I'm going to hit adapt model teeth. That's going to do the majority of the work for us. It's going to expand out. So again, what I've sort of taught recently is that expanding out into your preformed or your pre-op scan is a bit easier for the software than to shrink down, and you don't have as many seams. So that looks pretty good. And then we're going to have another free-forming option here. So at this point, we're going to turn off pre-op by pressing P, and I'm just going to go through, and I want to just smooth all of our borders here first. That's usually what I do first, is just smooth this area. Just going around and I'm holding my mouse down, my left mouse down, and just letting the smooth tool run, sort of like you had a hot wax paintbrush and you were just kind of painting this wax area. Sometimes if you have let's accentuate this. So sometimes if you have like a ditched out area like that, and you go to smooth it and it doesn't fix it, the way to do that is to over add. So add a bit, get it bulky. I mean, you can go really crazy, right? And then smooth that back. So I'm just holding and painting. I'm holding my mouse down and just painting, and now we fixed that problem. So if you have a ditch like that, adding and smoothing back is the way to do that. So some convenient shortcuts here. So if I hold Shift and click the middle mouse scroll button, if I click it down, that's going to make this halfway transparent, and that's going to allow me to see this right here, and I can smooth that like that. Okay, hold Shift again, click the middle scroll, turns it back fully transparent. Here's our occlusal contacts. I like having the scale in the middle. I think that's a bit more precise. And then let's turn on adjacents. So one of these, just for the sake of fun, we're going to make into a healing abutment, and one of them we're going to make into a crown. So if we were making healing abutments, first let's just fix these contacts. So if we were going to make healing abutments, if we were going to make crowns, first of all, I'm going to just smooth this down from the lingual side so that I don't affect the contours of the facial, and I want to get it down to what I know works for whatever mill or printer that I'm using. But I generally think that that's a pretty good place to be. Kind of depends on what you're doing clinically. So this was a final restoration, you know, I kind of want this to be perfect. If it's delivering an immediate provisional, this needs to be a little lighter than perfect because you don't really want this to touch the adjacent tooth. You want this to be just a little bit like off the adjacent tooth so that when the tooth next to this implant flexes, it does not push on your implant and cause your implant to fail. So, you know, something maybe more like this, where I have a quite obvious like gap, which I don't have yet, see? So reduce that even more. Starting to get there. Okay, so you get the point. Like I really almost want to have a slightly open contact. That's getting closer, but not quite there yet, all right? That's better. See that? That's an open contact. That's also going to make your fitting a little bit easier. Because after all, this is just planned. This isn't the actual patient's position. So when that implant gets placed, it's going to be off a little bit. Giving yourself a little space there is going to be more helpful to seat this intraoperatively, but you don't want these two things touching for an immediate implant because this flex of this tooth, the biological movement of this tooth can push on the implant and help contribute to failure. All right. So yeah, we definitely have some tooth contour issues here, don't we? So let's, just for the sake of sort of demonstrating this, so let's say that that was a great contact. We're also going to do the same here. Kind of a poor contour there that formed that we got to sort of fix. I'm not really sure why that happened, but that is a bit of a challenge. If you hold shift when you're on the smooth tool, if you hold shift and click, you'll get a flatten sort of mark. It's a very aggressive smooth tool, but sometimes that can help you to shape and recontour things. Okay, great. And then let's go over to anatomic tooth parts and let's push this out into that other tooth right there. It's looking better. All right, so let's just say for the sake of this tutorial that is good. We would need to spend a little bit more time on that, get some symmetry, but this would be ready to almost finish up. So, but like I said, we're going to do one provisional. So this would be on a tie base, and this one is going to be disc milling. So we can see our tie base sort of here. This is what that is. And this is basically milling or printing right to the platform. So what I'm going to do for this is I'm going to grab the entire tooth and just literally squash it down and then use the freeform tool and make it big and be really aggressive. I'm going to hold down Shift and just flatten this all the way with the Shift key like that. And then do a few more flattens and then do some smoothing. I want to flatten this area. You remember, if this is going to be a healing abutment, this has to fit underneath, an interim prosthesis or something that's bonded in the mouth. So it needs to be low profile. You don't want this sticking up tall. This is the scan data turned on. I think having a little bit of profile in the front is okay, but definitely I want the palate to be very, very flat. And then that's the minimum thickness point showing through. So it's going to just pop back up when we design this. All right, so that is reasonable. And then let's go next. We're going to make screw channels. Here's our screw hole design. And here are our merged parts. So there is our, possible 3D printed, customized healing abutment. So we're already starting to train the tissues at time of surgery. So awesome. And this is a provisional that we would put on a tie base that could be used for an immediate provisional or a provisional at stage 2. Now, even if you make this pre-surgically, this provisional, it's not a bad idea to bring it to surgery and use this to help time your implant. So the surgeon will use this to, obviously they're going to place the implant with the guide and they're going to time it with the guide, but they can sort of test fit this part in. And if they get this part to drop in, they know that the implant they placed is matching the virtual implant that was designed in the software. And then they could bury that implant, whatever, for whatever reason, tissue grafting, bone grafting. And at stage 2, assuming that implant didn't spin or move, this provisional should pretty much go right down and be delivered. And then at stage 2, you're allowing the tissue to heal to that implant, and you're going to get the best tissue response when it's healing to basically during the healing process. So at time of surgery, when you deliver something that shapes tissue, that's going to be your best healing process. Not, squashing the tissue with a crown at time of delivery. All right, so that's it. And these parts, they're all merged. They're already in our patient library, and they're ready to be milled, or you could print both, or whatever you want. So this is how you make crowns and provisionals from an ExoPLAN file and actually bring that in to have pre-surgical parts made prior to your patient's surgery, ready to go. All right, thank you.